So in this video, we're going to be going over the power properties of exponents. Now, the two we're going to zoom in on are the power rule and the power of a product rule. Before we get into that, let's just review real quick what a power is. So here we have b to the x is the exponent, b is the base. So this is saying you have x factors of b. Now remember, factors, those are things being multiplied. So this says that we have x amount or x number of b's being multiplied. Looking at the power property, this is an illustration of how we get it. So this is saying that we have 4 squareds being multiplied. So there's 1 4 squared, there's a second 4 squared, and there's the third 4 squared all being multiplied. Now each of these 4 squareds we can expand out a little bit more. So here's 2 4s being multiplied, looks like that, times another 2 4s being multiplied, and then a third group of 2 4s being multiplied. So for a grand total of 1, 2, 3, 4, 5, 6 fours being multiplied. So, and again, you can just look up here. Here we have 3 groups of 4 squared. 3 groups of 4 squared. So 3 groups of 2 4s, 3 groups of 2, it's 3 times 2, right? So anytime you have a power to a power, you are going to multiply the exponents. Product to a power, here we go. We have a number and a variable, or 2 numbers or 2 variables to the second power. So we have 2 a times b's. So here's an a times b times another a times b. There's 2 a times b's. Now if we look here, how many a's do we have? We have 1 a there being multiplied. There's 2 a's being multiplied, and then 1, 2 b's also being multiplied. So here we're going to have 2 a's times 2 b's being multiplied, 2 a's and 2 b's. So in this case here, that squared, or the 2, the exponent, it gets applied to all the factors. So the 2 goes to the a and the 2 goes to the b, whatever those might be, whatever values or variables they might be. Now this kind of looks and feels a little bit like distributive property, and it is. However, we can't actually say it's distributive property because distributive property only works for multiplication over addition. This is exponents. So we just call it the product to a power property. And again, it has that distributive type feel to it, but it's mathematically incorrect to call it distribute. So here's the 5 examples we're going to do in this video. If you already think you got this down, go ahead and pause the video, give all 5 a try, and then come on back and see how you did. So here we have y to the 3rd power to the negative 5th power. So we have a power to a power. So we are going to be using the power rule. So anytime we have a power to a power, we're going to multiply the exponents. So that's going to be y to the, and then we're going to do 3 times negative 5 for our exponent. We have a positive times a negative, so that's going to be negative, and then 3 times 5 is 15. So y to the negative 15. Now, if you remember with our negative exponents, anytime we have a negative exponent, we can kind of think of that as a reciprocal idea, or it just goes in the denominator, but we change it from a negative 15 to a positive 15 there. So, and you do have to read the instructions. Sometimes it says don't write negative exponents in your answer, so this would be your answer. Sometimes it says no fractions in your answer, so you'd have to go with this top one here. So you do have to read instructions to figure out what the format of the correct answer that your teacher is looking for would be. All right, so let's check this out now. Here we have w to the 3/4 to the 5/6. So we have a power to another power. So that's going to be power to a power, or power rule. And so we are going to end up multiplying the exponents. 3/4 times 5/6. So 3 times 5, that's going to be a 15. 4 times 6 is going to be a 24. But wait, there's more. We can reduce this as well. These are both divisible by 3. So 15 divided by 3 is going to make a 5. And then 24 divided by 3 makes an 8. So we removed a factor of 3 from the numerator and denominator, giving us w to the 5/8. Now, if you did want to simplify this a little bit, or make it a little bit simpler for you, you can do like cross-canceling type of idea. You can remove those common factors before you multiply. So here we have a 3. Here, the 6 also has a factor of 3 in it, or you can divide out a 3. So 3 divided by 3, that makes a 1. 6 divided by 3, that makes a 2 there. 1 times 5 is 5. 4 times 2 makes 8. So 2 different ways of multiplying those fractions there. Here we have 5u to the negative 2 power. So this does have a negative exponent, so we can use the negative exponent property or rule. And remember, with those types of things, that's where it's a reciprocal type idea. So that 5u is going to be in the denominator to the positive 2 power. Now remember, here we have a product to a power, so that 2 is going to go to the 5 and it's going to go to the u. So here we go. 5 to the second power, that's going to make 25, and then u to the second power, that's going to be u to the second power, and that one's done. So here we go. We have a to the negative 5th power, c to the 7th power, all to the 4th power. So first up, this 4 is going to go to the a factors and it's going to go to the c factors. So that's going to be the power of a product property. So that's going to be an a to the negative 5 times 4. So negative times positive is negative. 5 times 4 is 20. And then we're going to have c to the 7 times 4. So 7 times 4, that's going to make 28. Now we do have a negative exponent here. Some teachers are fine with that. Others are all like, no, no, no. We only want positive exponents, so we're going to use the negative exponent property. So we have an a to the negative 20th, so that's going to go reciprocal idea. That's going to go in the denominator. It's going to be a to the positive 20. And then that c to the 28th just stays in the numerator as c to the 28th power. So let's look at this example here. We have 9, x to the 3rd power, z to the 4th power, all to the 5th power here. So again, this 5 is going to go to the 9. It's going to go to the x cubed. It's going to go to the z to the 4th. We're going to use the power of a product property. So that's going to be a 9 to the 5th power. Now, the reason why we're leaving it in exponential notation instead of multiplying it all out is because 9 to the 5th power is a pretty big number. So kind of the rule of thumb is if it's like around 100 or less, go ahead and just write the number out, the value, in standard form. But if it's going to be a really, really big number, just leave it in exponential notation. It'll be a lot easier to work with that way. Next up, we're going to look at our base of x. So we have x to the 3rd to the 5th. We're going to multiply 3 times 5, giving us x to the 15th power. And then last, we got the z factor. So z to the 4th to the 5th, that's going to be z to the 4 times 5, makes 20. And boom, there we go. So a quick reminder, do get these formulas in the formula section of your notebook. Today we went over the power rule and the power of a product property there as well.